Thank you for staying tuned to this very time. So we are going to continue from where we stopped in my last video. In my last video, as I said earlier, I need to make that video short so that it's not be too long, so we can have time to continue the next properties of exponents. So it's not be boring. So let's go straight to that video right now. So if you are new to my YouTube channel, please kindly click on the subscribe button below so you get notified whenever I upload subscribing videos. Yeah. So without wasting much of a time, we are going to be looking at quotient rule, right? So how does this work? So quotient simply says that we have a into n over we have a into n, right? So there are several ways we can express this. I'm going to show you the two ways, okay? So that for understanding sake, so everybody can be carried along. So now, as I said earlier, a, as you see, is a factor. So and it's also the base too. So it's a number that must always look alike. So if I take an example, so let me further express this. This can be further expressed as a, right, becoming n minus n. Yes, so that can further be expressed in that form. So if that is expressed in that form, so so it's to tell you that a must be the same number, while m and n can always change at any time t. So we don't expect that to be. So this is the general presentation. So the other way, I'm going to clean this up anyway. So the other way we can write this, however, there's a clause. So provided this is true, provided a is not 0. Of course, once a becomes 0, when there's nothing to do here again. So therefore, so provided it is true, it will be undefined. Okay, you will not be able to solve. So this is true provided a is not equal to 0. So the other way this is normally expressed for some of us might be familiar with, so is a raised by m divided by a raised by n. So you can see your expression comes in either this form or this form. So you should be able to manipulate this and this. They also look alike, so it's not as if they are different. So this becomes a into m minus n, right? So we'll quickly take an example that illustrate this. So this is not a live video. If this was a live video, I would have asked you to give me a number what you would like to choose, but I can read your mind. I'm very sure for some of you here, you will pick, if I ask, okay, what number do you want to give as a, I'm sure a lot of you guys will pick 2. All right, so let me just follow your mind. Okay, so let's take example. Yeah, get this a good place. Let's take example 1 on this. Right, let's say a is 2. So I'm going to use this and I'm going to use it as an example anyway. So let's say a is 2. I'm going to say 2 raised to power. So m, I'm sure some of you will give me m to be what? Let me just guess 3. Right? So m to be 3. Alright, so I'm going to solve this in 2 different ways. Alright, I'm going to solve this in 2 different ways so that everybody's carried along, right? So let's say I'm going to pick the first number to be the lesser number, while the other one to be the bigger number. So m is 3 and also what? N is what? 5, right? Considering this part, I'm following this part, alright? So if I follow this part with another example, I'm going to say a to be what? I'm still going to use 2 as a, so I'm going to use 2 as a, but I'm going to make m be a bigger number, alright? So let's say we give m 7, right, divided by, and we'll give n, which is 2, sorry about that, give n 2, sorry, let me just put 4, right? So now you understand that I want to show you how you can manipulate in case, because what you might be familiar with is when the m is bigger and the n is smaller, so some of us might get confused. So let me just quickly work this out. So this becomes 2 raised to power 3 minus 5. However, if you observe, the expression already has negative expression already. So minus, because this now becomes 5, right? That's what it says here. This translates to this, right? So the same thing we apply here too. We have 7 minus 2, right? So if this is the case, so what now happens here? We now have 2 raised to the power what? 3 minus 5, obviously that will give you minus 2, right? 7 minus 4, pardon me, 7 minus 4 will give us 2 raised to the power what? 3, right? So if you apply the index example I gave earlier, I gave us example in 2 from that. Your index can be a raised to the power n, and it can be a raised to the power minus what? N. Whenever it's a raised to the power minus n, is further expressed as 1 over a raised to the power n. I believe that is, I mentioned that the other time. And this is what we are currently seeing right now. So this first part look like this, a raised to the power minus n, while this look like a raised to the power n, right? So you can see that the previous class. So if you have not watched my previous video on this topic, please kindly go. I'll drop the video link below in the description, so you can actually watch it, so you understand that part. But if you get it like this, fine. So now this can be further expressed as I'm going to rub this guy off here. I'm going to take this off. I believe this is clear already. I'm going to take this off. So this can be further expressed as a minus n will be given as 1 over a n. So now we have in representation 2 raised to the power minus 2. So this will further expressed as 1 over 2 raised to the power what? 2, which is 1 over what? 4. I said earlier, your index, when you have 2 raised to the power 2, it means 2 times 2. 2 in 2 places, because your index is 2, right? So for this, that we have a raised to the power n, so this further expressed at 2 raised to the power 3 will becomes 2 times 3, 2 times 2 times 2. When you work that out, you can put your figure there, and you can do that. You are very smart people. So, and that is all about this rule. We call it the quotient rule. What I mean, right? It's called quotient rule. Just put that up there. It's called quotient rule, right? So, and that is how this is expressed. I hope it's clear. If it's not clear, you can go back to rewatching the video. Let me just explain how this is done again. Though I've cleaned the general representation, but this is the question exactly. So 2 is your base, right? 3 and 5 are your exponents or your index. Alright, so this is the quotient rule. So what you do is you take the base are always the same. You put it and you put the index 3 minus 5, because this is division, so it becomes 3 minus 5. So this applies here. So this is that similar question but different representation. So this is when you see division, it becomes negative, right? So 7 minus 4, so this becomes 2 raised to the power 3, and this becomes 2 raised to the power minus 3. So I just needed to show you how to. So whenever you have whenever your index becomes what? Negative, your exponent becomes negative integer. So this is how to express it, that I took further to becoming 1 raised to the power 2 raised to the power 2 here, right? And this can be expressed further. I believe this is clear. So I'm going to solve one last example on quotient rule where your index is negative, right? So how will you manipulate that? So we are going to quickly do that right now. So, and that will be the last example for this video, so that we can continue in our next video. Yes. Okay. Still on quotient rule anyway. So still on quotient. So I'm going to take one example two on this. So I'm going to say so let me just write the general expression so that we can follow along. So we have a m divided by a m, or a raised by m over a raised by m. Whichever way the question is presented, they are still the same. So I'm gonna say, let's assume A. Let's still maintain A to be 2, right? Okay. So I'm gonna say A. So I'm gonna take an example on this. So A is 2. Let's say A is 2. So I'm gonna make it such that one of the index we have a negative number. Okay, I'm going to take two examples on this where m will be negative and n will be negative, right? And m will be positive and n will be what? Negative, right? So I'm going to say this is 5, right? Divided by 2 raised by minus 3, right? So I'm going to take this to be, so let's just quickly solve this part first. So this becomes 2 raised to the power 5 minus. Now if you observe, normally this rule, the division turns to minus, right? So and your index already has minus, so you're gonna be careful with that, so that you don't ignore that negative sign that is in front of 3. Very important. So I'm gonna so that you're gonna put in this form, this minus 3, you put in this form, right? So that you take cognizance of that 3. Most students will neglect it, or will ignore the 3. You can't get it right, so you must put that into consideration too. So this becomes, and from your rules of mathematics, where we are taught minus times minus is what? Plus. Plus times plus is plus. Minus times plus. You can give me the answer. Drop in the comment section below. I love to see. Alright. What was the first guess? Don't lie. What's the first guess? So minus times plus is what? Minus plus times minus is what? Again, what's the answer? Is what? Minus. So we are going to apply that simple concept here. So we have if this is not clear, I will do a video that explains all of this. So for those that are probably watching this video and you fully do not understand all these concepts, so this will become 2 raised to the power 5. So because minus times minus, because this is, there's a multiplication sign here that's invisible that you cannot see. So it's there. So minus times minus here will give you what? Plus. So that's why this time becomes plus 3, right? So this answer becomes 2 raised to the power what? 8. So you can leave it this way, or you express it in exponent form, which is 2 times 2 times 2 in 8 places. So you get your answer coming out to you easy and clean. So this is one part of the example. So the other part of the example I'm going to be showing you guys is when you have 2. Now when 5 is negative, right, divided by what? And you have now we have that with, so and we have 2 is positive, 3 is positive, right? So how can it be expressed? So let's quickly look at that. So this example, I believe this is good. So if we had 3 to be negative, we have 5 to be positive. So now we are having 5 to be negative and 3 to be positive. So we are still going to solve in a scenario where both indexes are negative. So let's quickly run this. So this becomes 2 raised to the power 5, right, minus 3 is equal to 2 raised to the power. Now most students have challenge with manipulating 5 minus 5 minus 5, where if you have a calculator there, you can easily do this with your calculator, your scientific calculator, or whichever calculator you have there. But there's probably for those in the junior class, maybe in the from whichever country you are watching the video from, can't say, but I'm speaking from Nigeria right now. This for those in the junior school, that is junior secondary school. Okay, it's called it this will become, so they will use a concept called number line to really understand this. For those in the senior class, you should know by now minus 5 minus 3. If you get the answer right, you can drop it in the comments below before you see what I'm going to write here. Alright, just be honest anyway. So we can, yeah, we are all here to learn. So this becomes minus 5 minus 3 will give you what? Minus 8, right? So if you got that, kudos to you. But if you do not get it, that, I'm going to just stay to subscribe, so that in my next video I will show you how you can easily uh do get this correctly. It's very easy. Maybe my next video I might work on it. So if you want me to work on this video, drop in the comment below, and I will definitely do a video that explain this, so that you can learn and also share to your friends and proceed that might need this. Okay, so that's what we have there. So once you have this, as I explained in my previous video, please do watch that video. That is very informative. So this becomes 1 over 2 raised to the power 8. The rest can be further simplified by putting 2 in 8 places, right? So the third example we're taking here will be 2 raised to the power minus 5 divided by what? 2 raised to the power minus 3, right? We'll go for a short break right now. When we'll come back, we continue. Yes, okay. So yeah, we are back again. So let's just proceed anyway. So this becomes 2 minus 5 minus, now as I did earlier, you must take this minus into consideration. So because this minus is already from the expression already, so this becomes minus what? 3, right? So this equal to what? 2 raised to the power what? Minus 5 minus times minus, as I said here, is plus. So this becomes plus 3. So before I put out the answer, can somebody tell me minus 5 plus 3, what will be your answer? I'm waiting. Well, before you proceed to check the power arithmetic, please kindly drop it in the comment section below. It doesn't matter whether you're right or wrong, right? So this video is an educational video, so it's meant for learning. So it's so don't feel bad and then not be disturbed. All right, so let's go. So this becomes minus 5 plus 3 is minus 2. So this becomes 2 raised to the power what? Minus 2. So once you have this as what it is, so this becomes, as I said earlier, 1 over 2 raised to the power what? 2. This can be further expressed as 2 in 2 places. Thank you so much for staying tuned to the end. Let me just run this part through. This is a quotient rule. Okay, so I did 3 examples with this is the general expression. It can come in this form, can come in this way, whatever, in whichever way it comes, you're able to manipulate it to put them all in this form. So I did, when it's negative, take note of negative sign that is with your index, so you put it out in brackets, so you can easily manipulate it by following this simple rule of this sign rule, that's minus times minus, it gives you what? Plus. So minus times minus gave us plus. So 5 plus 3 is 8. 2 raised by 8 can be further simplified by putting 2 in 8 places. So if you have a scientific calculator, you can just quickly punch it and say 2 raised by 8, and that gives you your answer. There you can put it in your notes. So the other part, I took an example where the first exponent is negative and the second exponent is positive. So this gave us obviously our rule in view of negative sign. So this one minus 3 minus 5 minus 3. So that gives minus 5 minus 3 will then give you negative sign. So that will be minus 8. So that landed us here. I've done a expression that explain how why this is like this, and my previous video. So another last example that has the 2 index are negative. So it's very important, you know. So this so minus, so this becomes minus further expression. As I said earlier, this negative sign taken into condition there, why this put in bracket, because we need to respect the fact that negative 3 is carrying negative sign. So that's why this bracket is introduced, right? So you should know now when I study mathematics, you must understand the reason for each step, right? I introduced bracket here because I need to hold and respect negative 3, right? So put negative 3 so that we can easily use negative 3. So if we can do that easily, so then that means that so that we can keep this, so that because if you don't do that, if you don't put 3 in brackets, you might get confused and write this. I want to do this, you get minus 8, which the answer will be wrong definitely. So putting 3 in bracket just make you see that 3 has its own negative sign, so you're going to work that out. So minus times minus will give you what? Plus. So that becomes minus 5 plus 3, right? So that leads us to minus 5 plus 3, which is what? Negative 2. So and this is further expressed as that as it is. So thank you so much for staying tuned to the end of this video. Kindly click on the subscribe button below and also click on the bell button so you get notified whenever I upload subsequent video. Thank you so much. My name is Imo Friday. See you in my next video. As we continue, we have taken 3 of these, right? I think so. We have done product rule, we have done quotient rule, and we have done power rule. In my next video, we'll look at raising a product to power. We're looking at raising a quotient to a power, yes, and we'll look at one last one in a negative with negative index. So thank you so much. See you in my next video, and bye bye for now. Okay.